Hello, this is Kyle Moore with Mech 330, Programming for Industry 4.0. We are working on the hardware portion of Week 8, the files. So in my previous video, I showed that we went through a command prompt program and created these light sequences and saved them to a file. So basically what we're doing for this video is I went and created 3 more videos, or 3 more files that we're going to be pulling from. So there's a total of 4 files, and we're going to be lighting up the light sequence on our Circuit Playground Express. So let's go ahead and go through it. It's a pretty lengthy code. I'm going to try to explain it as best as I can, as fast as I can. So I went ahead and imported some libraries. So board time, digital I/O, and then OS, Adafruit, Circuit Playground. I imported the CP, and then I created some functions here. So this function basically opens up this light sequence file from the lights folder, and it pulls and returns the line for the LED sequence. So the light sequence, or the first sequence, or the first list that was there in the file. And then so this is what this does. So with open, so we're opening that file as a read, and we're saying as F, so as a file object. And then we are creating a variable, and we're assigning it to f.read.splitlines. So basically what that does is, if you don't put like split lines or anything like that, if you have any of like the \n, \t, any of that, if you do just f.read, f.read will read the entire file. But if you do like f.read lines, it will actually pull that /n, and because it adds it to it as a string, because they are in there as strings. So, but if you do split lines, I found that removes any of the \n, \t, any of that stuff. So, and then we created another variable here, and we are assigning it to this variable 0. So the first line, 0. Remember that in most things, 0 is 1. 0 equals 1. Anyway, and then we're returning that that variable. Same thing on this one, but with time on. So yeah, it's literally the same thing, just with the second line that's in the file. And then we're using a little bit of sound today. Wasn't required. I just wanted to make it a little bit fun. So this is basically a C scale. So C4, E4, G4, and then C5. I had to look up those numbers. That's the hertz, the frequency for those. And then here we are basically assigning the left button, the pin D4. We're assigning that as an input and a pull down. And then this one is the right button. We're assigning it to D5 and as an input and pull down as well. So cp.pixels.brightness. So cp.pixels, that's what this was imported for. And also I've been using the NeoPixel library, but if I wanted to use the sound, this was the easiest way to do the sound. So if I had the import CP, I was not able to also use the NeoPixel library. It was throwing a big hissy fit. But you can still use the pixels with the CP, so cp.pixels. We're setting the brightness at 30%, and then we're assigning the pixels to a variable. We created a variable and we assigned it to the lights folder, so \/ lights. And then we are counting how many files are in there, just because, I guess. I didn't really have to do that, but I did anyway. We're creating another thing here. This is select counter. This is kind of like the file var variable in the software video. if you watch that. So basically this is just saying, because the files are called light sequence in, so there's a number there. This is that number. And so we're going to be using that to open up the different files, 1, 2, 3, 4. And then here we are creating a variable and we're assigning it to the whole file. So the whole file name. So this is the path that we're opening from. So the directory or folder. And then we're using the select counter here. So this is 1. And then we are creating or opening up the light sequence, or basically anything that's in there. But the only thing that's in there right now is files named light sequence in. So then there's a big message that we're going to be printing in the serial monitor. And then we are setting a variable called program active, and we're setting it to false. We are while that variable is false, if you use the switch, so if you turn the switch on, so there's a little switch in between the two buttons. If you turn that on, it'll play the sound, that C scale, and then it'll set that program active variable to true, and then it'll print a message. And then while the program active is true, we are using the try exception, because once we keep increasing that select counter, the file name variable, once it gets past 4, so 5 doesn't exist, and so it's going to throw an error. So basically we're using the try except to basically ignore that error and return back to 1. So, and I'll go over that in a little bit. So if the CP switch is false, so if we turn the switch off, all the lights will turn off, and it'll just continue to sit there and repeat the loop. And it'll turn the program active to false, so it'll jump back to up here. And then if the switch is still on, it will turn the first light on, and it'll set it to green. And then we are loading both of these functions up here, and we are using eval. So eval, what that does is it basically, so we created the list in the software portion and wrote them to the files. So they wrote in the form of a list, but they are actually strings. So when you load the file, it loads them as a string, but they are still in the format of a list. So if you do eval will say, hey, this looks like a list, we're going to make it a list. So the type will now be a list, and we're assigning it to these variables here. If the left button is pressed, all the lights will turn off. It'll turn the select counter, it'll add 1 to the select counter, so it'll go to the next file, basically. It'll play a little tone for funsies. And then if the right button is pressed, it'll turn off all the lights. And then here's something kind of cool. So for AB in zip, so what zip does is it lets you iterate multiple lists at the same time. So basically, let me go ahead and open up one of these files for you really quick to show you. All right, so here's the two lists. So this is the LED list, and this is the time list. So basically, it's going to iterate both of these lists at the same time for each one. So what I mean by that is, so it's going to turn on light 5, which will actually be light 6, and it's going to turn it on for 2 seconds. And then it's going to go to light 0 or 1, the first light, and it'll turn it on for 1 second. And then it's going to go to light 9 or 10, and it's going to turn it on for 3 seconds. And so that's so zip is a pretty cool little function that I did not know about, but I'm glad that I found. So basically, with that, so for each one of these, and 2 of these lists, so for each value, A, which is each value in LED sequence, and then B, which is each value in time sequence, for each one of those, so the pixels, we're turning on int A, so this has to be an integer. And because it's in a list and it has quotation marks on it, it's that part is still set as a string, so I had to make it an integer. And we're using A, so in LED sequence, the lights will be blue, so 0, 0, 255. This is RGB. And then time.sleep float, so I'm pretty sure it has to be a float here. I think I tried to use an integer, still can't be a string. But we're using the number in B, so this is the first instance of B, first instance of A, and then we're turning the light off here after that time has passed. And then here's the accept OS error. So as I said earlier, once I get past light sequence 4, there is no more files in that folder, and so it's going to try to open up light sequence 5. It doesn't exist. It throws an error. The whole program shuts down. But with accept OS error, I can say, no, I don't want you to throw that error. I'm going to turn off the lights. I'm going to set the counter back to 1, which would be the first file, and I want you to continue doing it. So I can just keep doing this forever, pretty much. So let's go ahead and open up the serial monitor. I'm going to hit save, and then I'm going to turn on my other camera here. All right, there we go. Okay, so as you can see on the serial monitor, it says turn on the switch to begin. So we're going to turn on the switch and listen to the sound. I don't know if you actually heard that or not, but yeah. Anyway, so the first light is green. So that is saying that we are on file 1. So I'm going to go ahead and open up file 1. So we have so the first light is 5, the second light is 0, the third light is 9, so it's actually 6. So the 6th light, first light, 10th light, and then for 2 seconds, 1 second, 3 seconds respectively. So let's go ahead and push the right button. So 6th light. And there you go. And then if I push it again, it does the same thing. Alright, now if I push the left button, it does a little sound, turns on the second light. So now we're on light sequence 2. So, light sequence 2, 83265. So we have 8, 2, or 8, 3, 2, 6, 5. Add 1 because it's, yeah, anyway. And then if we do this, boom, third light's on. So we're now in light sequence 3. So 1, 2, 3, 1, 2, 3. I went a little easy on this one. So 1, 2, 3. Boom. All right, and then for the fourth one, we have 3, 1, 3, 8, and then 1, 1, 3, 2. So 4, fourth light, second light, fourth light, ninth light. Fourth light, second light, fourth light, ninth light. For 1, 1, 3, 2 seconds respectively. And now if I push this again, right there, it would normally say OS error and shut the program down, but because of that exception, it did not. So it went right back to the first one, the 5, 2, 9, or 6. Yeah. Anyway, so yeah. So that's it. Thank you so much for watching.